Hello everyone. In this video, we're going to be taking a look at a couple theorems that deal with congruence transformations. So the first thing, just remember that a congruence transformation, all that means is we're looking at rigid transformations. So our image is congruent to our pre-image. So even in a composition of transformations, what we end up with is the same as what we started with. So what I'd like to do to take a look at these theorems, I want to do a couple examples that illustrates the theorems, and then we'll summarize what we saw, and we'll take a look at what the theorems say. So the first example I have says graph triangle ABC with these vertices and its image after this composition, and we're going to do two reflections. So we're going to do a reflection over the line x equals 2, and then we're going to do a second one over the line x equals -5. So these two lines, these are vertical lines. One of them goes through the x value of 2, like this. And our second one is going to go through the x value of -5. So 1, 2, 3, 4, and 5. So we'll do one reflection over x equals 2, and then we'll do a second reflection over the line x equals -5. So let me start by graphing this triangle. So A is 4, 1, 1, 2, 3, 4, up 1. B is 7, 4, so 1, 2, 3, 4, 5, 6, 7, and then up 4, 1, 2, 3, 4. And then our last vertex, the point C, is over here at 8, 1. So we have A, this was B, and then we have C. And then I'll connect these together to form our triangle. All right, so now let's do our first reflection. We're going to do the first one over the line x equals 2. So remember, when we're doing a reflection, the line of reflection ends up being the perpendicular bisector between your pre-image and the image. So perpendicular bisector, since we're looking at a vertical line, we're going to move horizontally. And then the second piece of that is our points need to be the same distance away on the other side of our line of reflection. So point A is 1, 2 units. So then we'll go 1, 2 units on the other side, and that's going to give me A prime. And then let's just do the same thing for our other 2 points. So B is 1, 2, 3, 4, 5 units away from our line of reflection. And then 1, 2, 3, 4, 5 units on the other side is going to give me B prime. And then our last point, C, is 1, 2, 3, 4, 5, 6 units. And then we'll go 1, 2, 3, 4, 5, 6 units on the other side to get C prime. And again, let's connect these together to form the triangle. So that takes care of the first reflection. Now we're going to take triangle A prime, B prime, C prime, and we're going to reflect this one over the line x equals -5. And we can do the same exact thing. So C prime is 1 unit away. So if I go 1 unit on the other side, that's going to be C double prime. B prime is 1, 2 units. So 1, 2 on the other side gives me B double prime. And then our last one, A prime, 1, 2, 3, 4, 5 units. So if I go 5 units over on the other side, here's A double prime. And I'll connect these together, and we'll get our final image. All right, so here's our final image, A double prime, B double prime, C double prime. And now let's just take a look at what we have here. So we started with triangle ABC, and then we reflected it once, and then we reflected it twice. So when we do a reflection, we do change the orientation of the triangle. If you notice what we started with, A was on the left side of my triangle. And now after I reflected it, A is over here on the right side. So that orientation flips. But then when I do my second reflection, it goes back to our original orientation. Again, A is over here on the left side of the triangle. So if I do 2 reflections, I get back to the same orientation as what I started with. And if we kind of take a look here, this double reflection is the same as a translation. In a translation, we don't change orientation at all. We just slide the shape somewhere else. And that's exactly what happened here. So even though we did a double reflection, we get back to the original orientation. and this is equivalent to a translation. There's also a couple neat properties about this, where if we take a look at the distance between our two lines of reflection, so in between x equals 2 and x equals -5, that is a distance of 7 units. Now let's take a look to see how far apart my original triangle is from our final image. So I'm just going to take a look at how far away A and A double prime are. So if I just count, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So the distance between A and A double prime is 14 units, which is double the distance in between our two lines of reflection. Also, our path here that we're translating, we're going directly to the left. It's a horizontal translation, which happens to be perpendicular to the lines of reflection. So that's our first theorem. So a double reflection over parallel lines is the same as a translation. Now let's take a look at my second example, and this is going to illustrate the second theorem I want to take a look at. So it's the same triangle, and now we're going to do a double reflection, but this time, instead of our lines being parallel, the lines intersect. So I want to do a reflection over the x-axis, and then a second reflection over the y-axis. Again, let's start by graphing the triangle. So 4, 1. And then B was 7, 4. 7, 2, 3, and 4. And C was 8, 1. So we have A, B, and C, and I will connect these together to form the triangle. All right. So here's our triangle. Our first reflection, we're going to reflect over the x-axis, so the horizontal axis. And just like we did on the first example, we just want to make sure that we go the same distance on the other side so that our line of reflection is the perpendicular bisector between our pre-image and our image. So here's A prime, and here's C prime, and then B is 1, 2, 3, 4 units away. So we'll go 1, 2, 3, 4 units down. We could also do this algebraically. We know that there is a shortcut for reflecting over the x-axis. Since we're reflecting it vertically, the only thing that changes are the y values. So here all the y values just become negative. So 4, -1, 7, -4. But I will connect these together. And here's our first step. And now we're going to take A prime, B prime, C prime, and let's reflect this one over the y-axis. So same plan. We'll go 1, 2, 3, 4 units. So then we'll do 1, 2, 3, 4 on the other side. And let's see, C is over here at +8. So it'll reflect to -8. And here we have +7 reflecting over here to -7. So here's A double prime. This was C double prime and B double prime. And connecting these together to get our final image. All right, and here's our final image, A double prime, B double prime, C double prime. And again, let's just take a look at the results. So as we discussed in the first example, we know that a reflection changes the orientation of our shape. So you can sort of see we have B on top, and now we reflect it, and then B's on bottom. The order as we go around, if I were to go clockwise, I would go A, B, C. But if I go clockwise around my first image here, it's A prime, C prime, B prime. So the order of those vertices changes. But after we do the second reflection, we're back to our original orientation. In this case, A double prime, B double prime, C double prime, it's actually just upside down compared to what we started with. So a double reflection over lines that are intersecting, what we end up with, this is the same as a rotation. So the point of rotation is actually the intersection between your two lines. So I have my two axes here. The point of intersection is the origin. So you can imagine if I rotate ABC around the origin, I can end up on our final image, A double prime, B double prime, C double prime. The angle between our two lines of reflection, since there are two axes, the angle here is 90 degrees. And then the neat property about this example is that the rotation that we end up with, that angle of rotation is double the angle between your two lines of reflection. So the angle between the x-axis and the y-axis is 90. So this is the same as a rotation of 180 degrees because 180 is just double 90. And that's our second theorem. So a double reflection over intersecting lines is the same as a rotation. So now let's take a look at these two theorems written out. So the first one, if lines K and M are parallel, then a reflection in line K followed by a reflection in line M is the same as a translation. So this was the first example we took a look at. So your two lines, as long as they're parallel, if you reflect over one and then the other, it's the same as a translation. Furthermore, the neat property we saw is the distance between your original image and your pre-image. That distance is twice the distance between your two parallel lines. So however far apart K and M are, the translation is twice that. And then the second one we saw, if lines K and M intersect at point P, then a reflection in the line K followed by a reflection in the line M is the same as a rotation about point P. So if two lines intersect and we reflect over both of them, it ends up being the same as a rotation about the point of intersection between those two lines. And the property we saw with this one, the angle between our two intersecting lines, so the angle formed by K and M, your rotation is going to be an angle that's twice as big as that angle between K and M. So two neat properties, two double reflections that are the same as some of our other transformations.